Okay, this next section is a fairly easy section, to be honest with you, but it's not, there's not much to it. I'm not sure why it's in here, but it's to basically decipher the difference between inductive and deductive reasoning. So basically what you have to do in this section is just take down examples and take down some vocabulary in order to get ahead. But pretty much all you're doing is studying patterns and having to solve questions based on patterns. One of the things that we will do is Sudoku puzzles towards the end of this. Those have to do with the type of reasoning that we need to use in order to solve those puzzles. But first of all, what we look at is we look at the types of reasoning. On page 4, there's a couple things that you want to first make note of. Without reading it, does anybody know what a conjecture is? Anybody heard that word before? Okay. So a conjecture basically is a statement that's not proven. It's a statement that you make. So when you did science experiments, whether it was in elementary school or high school, when you do science experiments, you always have to make a conjecture. You have to make a statement as to what you think is going to happen. That's basically what the conjecture is. All right, so it's based on unproven information, but you make a statement based on what you think the outcome is going to be. So it's an unproven conclusion based on evidence. Inductive reasoning involves making a general conjecture based on specific cases by looking at patterns and recognizing properties. Okay, so I said to you there are two types. There's inductive reasoning and there's deductive reasoning. Inductive reasoning is looking at the actual information that is presented to you and you come up with the conclusion from it. Deductive reasoning is taking information that has already been proven to you and coming up with a statement for it. All right? So this scenario right here, inductive reasoning, is you're looking at the patterns. You're trying to find out based on the patterns. Deductive reasoning, you would take something like the interior opposite angles of a parallel lines on a transversal are equal. Well, that is, you know that because that has been proven to be true in all cases. So that's where you would use deductive reasoning to help you solve. Additional evidence may support a conjecture but does not prove it. At some point, if you are able to prove your statement wrong, so we're going to look at how basically this whole section works out as to be its logic. All right, you're using logic in order to solve questions here. So you need to be able to prove everything 100% correct at all times or your conjecture fails. All right, and then you can adjust your conjecture at that point and change it so that it satisfies all possibilities. It says, draw a pair of intersecting lines, measure and record the opposite angles as shown. What conjecture can you make? All right, so it's asking for a statement about two lines that cross. So I have two lines. What do I know about this angle and this angle?
They're the same.
They're the same. Do we know what the names of those angles are? Do we remember? Not corresponding. Corresponding means in the same position.
Yeah.
There's no interior or exterior because they don't have parallel lines.
Opposite.
So they are opposite. We call them vertically opposite. So we are basically saying that this is equal to this. All right? Now, we can do our own reasoning behind it by measuring it. That would be inductive reasoning. You would draw multiple lines and cross them, measure those angles. You would end up with exactly that. Those two angles are equal. Now, deductive reasoning, I would label them like this. and A, B, C, and D. Okay, now I don't want you to do this. Just leave this, don't write this down. But here's what I would have happen. I know that A and B add up to give me what? 180, because they are on this line right here, and it's intersected. So I have A plus B is equal to 180 degrees. Now that's been proven to us. We know that a straight line has the measure of 180 degrees. Okay? And B and C, they add up to give you 180 degrees as well, correct? Again, been proven to us that the measure of a line is 180 degrees. So we know that. So if I arrange these different, I would get B is equal to, do that again. I would get A is equal to 180 degrees minus B. I would get C is equal to 180 degrees minus B, right?
There's a bunch of different ways you could do it though, right?
For sure. And based on this right here, that if that is equal to that, then what do we know? A is equal to C. Well, that's a type of deductive reasoning. I have used something that has been proven to us already in order to prove my conjecture, which is vertically opposite angles are equal. Or the geometrical way of saying it is if they are exactly the same, we call them congruent. So vertically opposite angles are the same. The inductive part of this would be you actually physically measure that using a protractor. And no matter how many times you draw it, those angles will be equal. That would be the use of inductive reasoning. Okay? Let's look at the second example. 1 plus 3 is equal to 4. 3 plus 5 is 8. 5 plus 7 is equal to 12. And 7 plus 9 is equal to 16. Okay. So just based on the pattern that's been drawn for you, what do you see that's happening next? Okay, so say that again.
You're going up by 4.
What's going up by 4?
Total.
The total, the sum. That's right. You're absolutely right. The sum is going up by 4s. But what has to happen, what's happening on the left side here? Okay. So what else can you say about it?
Well, it's going up by 4 each time.
Each equation goes up by 2.
4. Because you're replacing the 1 with a 5, so that's 4 more. Pardon?
Replacing the 1 with 5.
Well, what?
Replacing 1 with a 3.
Yes, and the 3 with the 5, so that's 2, and 2 is 4.
Oh, that's super. Yeah.
Okay. So that's right. All right. Now, can somebody give me another conjecture that's actually going to satisfy this? Okay, so you figured out that it's going to go up by 4. All right? I'm going from 1 to 3, 3 to 5, 5 and 7, 7 and 9, 9 and 11, 11 and 13. What's happening there? I have odd numbers, right? I also have consecutive odd numbers. Would you not agree with me?
Yes.
Consecutive meaning going in order, right? 1 and 3, 3 and 5, 5 and 7, 7 and 9. So what I could state here as my conjecture is that if I add consecutive odd numbers together, the sum is going to be divisible by 4. Would you agree?
Yep.
Okay, so let's pick any two consecutive odd integers and let's find out if the sum is equal to a number divisible by 4. So let's go with 17 and 19. What's 17 and 19? 36. Seems to work. Give me two more odd consecutive numbers.
15.
Sorry?
15 and 17.
15 and 17, what does that equal?
32.
32. Seems to work. Anybody else?
The big one. Yeah, go ahead. 51 and
51 and 53? What is that? 104. Is that divisible by 4?
Yeah.
Yeah?
twice
36.
So it seems to work every single time, doesn't it? So my conjecture holds up. The thing is, can you disprove this conjecture?
Probably no.
Is there an example out there that would disprove what I have just done here?
No.
Negative maybe?
Yeah, it's not saying negative.
Okay, well let's check it out.
-3.
So maybe in theory, right? 0 can be divided by 4. Right? What about if we go
-4.
-4? Is that divisible by 4?
Yeah.
Okay. Let's do -7 and -9. What do I get there?
-16.
-16. So basically it looks like if I add 2 consecutive odd integers, I'm going to get a sum that is divisible by 4. Okay, so it works. So that's what my conjecture can be. And if I can't disprove it, if I try everything I possibly can and I can't disprove it, then I know my conjecture holds true. All right? Now, I'm going to show you something that's going to be a little bit beyond what is needed from you, but eventually we have to work with this, so I'm going to show it to you. How do I make any number become an even number? Does anybody know?
You add the next consecutive odd number.
The next
Yeah.
consecutive odd number.
I don't know.
So what if 4 and then add 5? Does that make it odd?
Well, no, but if it's odd to make it even,
I want to make every single number even.
times it by 2.
Times it by 2. You agree? 1 times 2, 2. 2 times 3, 6. Okay? So you still multiply every whole number by 2, it'll make it even. How would I make it odd?
Times it by 3.
No.
3 times 3 is 9.
3
3
times
times
2 is 6.
3 times 4 is...
Yeah, so it doesn't work
Divide
every
the odd
time.
number by itself.
Divided by
Sorry?
Divide the odd number by itself.
That gets you 1.
Okay, so we're going back to the same number though, right? You're going back to the same number. So if I go 3 times 4, or 3 times 3, and divide by 3, I get the same number.
divided by 2.
Okay, just think this through for a second. Pick an odd number right now,
Right.
times it by 2. What happens to it?
It's even.
It's even. How do I change it back to being an odd number then?
Divided by 2.
No, subtract 1 or add 1. If I take any number, K represents any number, so give me an odd number.
19.
19. 19 times 2 is 38. 38 subtract 1 is 37. Give me another odd number.
59.
59. 59 times 2 is
118.
118. 118 subtract 1 is 117. So, as long as I do this, right, I can now change any number to an odd number. Okay? So, again, this is a little beyond you, but I need you to see this because we do use this. We need this notation later on. So 2k subtract 1. What that does is that states that I am going to make any number odd. Okay? Now, how do I show the next consecutive odd number? I'm going to do some fancy math here for you. So, how do I get to the next consecutive odd number? How do I go from 1 to 3? How do I go from 3 to 5?
Add 2.
How do I go from 7 to 9? I add 2. So what do I have to do to that number in order to get to the next odd number? I have to add 2 to it, right? So if I add 2 to it, I'm going to get to the next odd number. So what is the next odd number? Well, that would be 2k subtract 1 add 2. Right? Which is 2k plus 1. Okay, so what I've just done is I'm taking one odd number, I'm adding it to the next consecutive odd number, and my sum should be divisible by what? 4. Should be divisible by 4, right? Would you agree with me? Okay, I'm going to eliminate the brackets here. I'm going to eliminate the brackets here.
4K.
So I have 2k subtract 1, add 2k, add 1. What does that equal?
4K.
4k. Is that number divisible by 4?
Yeah.
Yes. Because if I multiply any number by 4, it means it's divisible by 4. So what I've just done is I have taken this numerical pattern right here, and I have proven that it works every single time using some algebra. Okay? This is just a type of reasoning, inductive reasoning, in which I'm going to prove my conjecture true. So as long as I can't find a value that's not going to work, that conjecture is always going to be true. This statement right here equals 4k. That statement right there means that if I add consecutive odd integers together, I am always going to end up with a number divisible by 4. All right? Now, we aren't there yet. We don't need to be there. It just, I'm showing you some of the things that we will eventually work with a little bit. Turn over to 1.2. I'm going to go through basically right to 1.4 today because it's not the same kind of math that you have been using. Okay, so a conjecture can be supported or disproved with further evidence, as I have just stated. You can revise a conjecture in response to new evidence. Are the horizontal lines in this diagram straight or curved? Make a conjecture, then check the validity of your conjecture. All right, so look at that diagram right there. With a show of hands, how many of you think that those lines are curved? Nobody in here thinks they're curved?
Just an illusion.
It's an illusion.
I'm too smart.
Anybody want to
focus on one?
go out on a limb?
Sure.
Okay, Austin?
Yep.
All right. What is the appearance? What makes this look like they're curved?
The
Lines
inside.
going out from the
The what? Sorry?
top. The other lines going out from the center. Horizontal.
Okay. What else? Yes. Yes. The circle in the middle gives you the illusion that you're going around it. Right? Now, those of you that have a straight edge or a ruler, check those lines for me. Are they straight? Or are they curved? Are they straight? All right. So that is an illusion. So you are going to make a conjecture. Your conjecture says that the two horizontal lines in this diagram are straight. Okay? I conjectured that the horizontal lines are straight and that the apparent curvature is an optical illusion caused by the diagonal lines. I put a ruler alongside each horizontal line. The lines were indeed straight. To verify my conjecture, I measured the distances between the horizontal lines. These distances were equal, so I knew the lines were parallel. Okay? So, that circle, they say the diagonal lines, I think it's the circle. I think that circle there gives you the appearance that it's going around the circle, even though they are the same distance from the circle at all times, because those lines are parallel. So that's what your conjecture would be. Let's look at the second one here. So this is where we get into a little bit more of the complicated part of this. Make a conjecture about this pattern. How can you check the validity of your conjecture? All right. So I have 1 plus 1 add 1 over 2, right? And that is equal to 3 over 2. I have 1 over 2 plus 1 over 3, and that's equal to 5 over 6. I have 1 over 3 plus 1 over 4, and that's equal to 7 over 12, correct?
Yep.
Now I got 1 over 5 plus 1 over 6, and that should be equal to 11 over 30. Yeah? 1 over 6 plus 1 over 7 is equal to?
Oh, I get it.
Do you? What is it, Jordan?
It's 5 times 6, and then that would give you 30.
Oh, go up here.
13
14.
Jordan?
Oh,
I think you got it.
I don't know.
It's 13 over 42.
Okay. So, Jordan, you had the bottom part, right?
Yeah.
Right? And then what goes up here?
13, yeah.
13. Okay?
Oh.
Somebody?
15 over 56.
15 over 56. Anybody not see the pattern yet? Be honest.
What's the pattern?
17 over 72.
If I take this times this, I get the bottom number. If I take this plus this, I get the top number.
Oh, that's maybe easier.
Well, you
Right.
add that.
Okay, so 8 times 9, 72, and on top, 17. All right, let's keep going because I want to find out, does it work at all times? 11 plus 12 is?
That is 23.
23. 11 times 12 is?
100.
132. Okay? So, if I did this,
Is that in the simplest form?
if I did this,
X plus Y over XY.
yeah, this is what we're saying. My conjecture can say x plus y over xy right there. Right?
Is there always a 1 on top?
That's the key to the question. So Brock's question was, does there need to be a 1 on top? The answer is yes.
So there
Has to be a
will
one.
be questions without a 1 on top. We have to make there be a 1 on top.
No. This is just a pattern. They just wanted you to decipher the pattern based on the information given to you. That's called inductive reasoning. Okay? So it works specifically for that. Okay, have a look at 1.3 on page 10. Still working with patterns. I like this one here. 11 times 11 is 121. 12 times 11 is 132. 26 times 11 is 286. And 43 times 11 is equal to 473. I'm going to try one more here. 52 times 11 equals. Okay. Second, hold on. Should work. All right. Somebody think they can see a pattern here?
Yeah.
582.
Front number is always like the first number. Well,
would be 5 in that case.
Yeah.
And the last number is always the second number, so if you do the middle number is those two numbers at 6, so 572.
572. All right. Worked?
Well, what about when you get like larger numbers, like
What do you say?
9?
Just wait. Just wait. 63 times 11.
692.
Go ahead. Somebody over here.
693.
693.
Pattern.
Explain it, Ella.
6 first, and then 6 plus 3 is 9, and then the 3 again.
That's right.
Oh, okay.
There's your first number. There's your last number. The sum of them is your middle number. Seems to be working, right?
Yeah.
Okay?
Just not it. It's not it.
714, I don't know.
704.
704.
But it doesn't.
What's the pattern tell us to do?
704.
700 and.
No, that's what the answer is. What does the pattern tell us to do?
No, 7.
No, 7.
Go ahead, Ella, you got it.
104.
6,104. First number is a 6. Second, the last number is a 4, and the sum in the middle. So what's the problem with the question? The way it's,
Gets to 2 digits, you gotta add the last two, or the first two numbers.
once you get to, say again?
Once you get 2 digits, you
Yeah.
gotta add the 6 and the 1, so the first two numbers.
Okay, well no, just tell me how the pattern breaks down here. That's what I'm looking for, Amber. How does the pattern break down here? Because 6,104 is not right. So what part of this is not right? Is the first number right?
Yeah. No,
The last number is right?
the last number is right.
Okay, so the problem is right here. So what's the problem with the conjecture that we were doing before? Single digit sum. As long as my sum is a single digit, that's going to work. But the moment I have a double digit sum with these 2 digits, the pattern breaks down at that point. Okay? So they predicted it by going with, which is neat. Okay? So here's what they say. AB times 11. First one is A.
AB 11.
A plus B, and then the last number is B. So that's my first number, that's my last number, and the middle is the sum of the 2 values. That's what that says. But as we went through the conjecture, the moment that we had a double-digit sum, it broke down. So then we could change our conjecture. So at this point, our conjecture should have stated, we take the first value as our first digit, we take the second value as our last digit, and the sum in the middle. But then we have to add in our conjecture as long as it's a single digit sum. Okay? Questions about that? So, conjecture, again, is a statement of what you think is happening. That's your observation statement. Your statement can be changed after you have taken in all the information. You can change that statement. All right? You need to finish from 1.1 to 1.3 for Monday. The end of 1.3. Okay, Monday we'll look at 1.4.
Hey, that's a lot of good.